Good morning and welcome to this next lecture on vibrations of plates and shells. We were doing the derivation for a rectangular plate using the Hamilton's law as given in the textbook. We were at this stage in the last class. We had seen the kinetic energy, the boundary terms and the external load. We were at this strain energy term. Okay. So if we look at the assumptions from Love, then capital U1, which is alpha 1, alpha 2, alpha 3, and let me just remind you that although I am using this alpha notation, alpha 1 is x, alpha 2 is y, alpha 3 is z for the plate. Okay. I am using the same notation so that students find it convenient. So this is equal to u small u1, okay, which is a function of alpha 1 alpha 2 plus alpha 3 beta 1, which is also a function of alpha 1 alpha 2. But in this case we are straight away going for pure bending, so we will say u1 is equal to alpha 3 beta 1. Similarly u2 will be equal to alpha 3 beta 2, okay, and u3 is equal to u3 alpha 1 alpha 2. Okay. Now most of the derivation was done in the general case, so I am going to use that. So sigma epsilon 1 is 1 over E sigma 1 minus mu sigma 2, then epsilon 2 is 1 over E sigma 2 minus mu sigma 1, and it will be useful to write this in the next page, so let us do that. Epsilon 1 is del u1 by del alpha 1, which is equal to alpha 3 del beta 1 by del alpha 1. Then epsilon 2 is equal to del u2 by del alpha 2, which is alpha 3 del beta 2 by del alpha 2, and epsilon 2 is equal to del u2 by del alpha 1 plus del u1 by del alpha 2, which ends up as alpha 3 del beta 2 by del alpha 1 plus del beta 1 by del alpha 2, and epsilon 3 is del u1 by del alpha 3 plus del u3 by del alpha 1, which ends up as beta 1 plus del u3 by del alpha 1, and epsilon 3 is del u2 by del alpha 3 plus del u3 by del alpha 2 is equal to beta 2 plus del u3 by del alpha 2. as before, the variation of the strain energy dt is equal to T1 to T2 integral over alpha 1 integral over alpha 2 integral over alpha 3, which means x, y and z is now I am straight away using the earlier expressions, plus sigma 22 delta epsilon 22 plus sigma 13 delta epsilon 13 plus sigma 23 delta epsilon 23 plus sigma 12 delta epsilon 12 d alpha 1 d alpha 2 d alpha 3 dt. Okay. Now using these definitions, this becomes integral T1 to T2 alpha 1 alpha 2 alpha 3 sigma 11 alpha 3 del del alpha 1 delta beta 1 plus sigma 22 alpha 3 del del alpha 2 delta beta 2 plus sigma 12 alpha 3 del del alpha 1 delta beta 2 plus del del alpha 2 delta beta 1 plus sigma 13 delta beta 1 plus del del alpha 1 delta u3 plus sigma 23 del beta 2 plus del del alpha 2 delta u3 d alpha 1 d alpha 2 d alpha 3 dt. Okay. Let me say here that this delta u will come with a negative finally, okay, the negative sign. Let's remember that, because that will affect all the signs on the boundary conditions and so forth. Okay. So now straight away this is a function of alpha 1 alpha 2 function of alpha 1 alpha 2 function of alpha 1 alpha 2 and so forth. So straight away if we integrate sigma 1 1 alpha 3, that gives me the moment resultant alpha 1 alpha 2 alpha 3 m11 del del alpha 1 delta beta 1 plus this gives me m22 del del alpha 2 delta beta 2 plus q13 delta beta 1 del del alpha 1 delta u3 plus m12 del del alpha 2 delta beta 1 plus del del alpha 1 delta beta 2 plus q to 3 delta beta 2 plus del alpha 2 delta u3 d alpha 1 d alpha 2 dt. Okay, so we number these now as 1, 2, 3, 4, 5, 6, 7 and 8. So we will take these one by one. So number 1 gives me integral, so there should be no d alpha 3, sorry, here that is done. So because there is a derivative with respect to alpha 1, we will take the alpha 1 integral m11 del alpha 1 delta beta 1 is equal to the integral of products m11 delta beta 1 at the edges of alpha 1 minus an integral alpha 1 del m11 by del alpha 1 delta beta 1 d alpha 1. Then we have 2, which gives me integral of alpha 2 m22 del alpha 2 delta beta 2. There should be a d alpha 1 here, d alpha 2, which is equal to m22 delta beta 2 at the ends of alpha 2 minus integral alpha 2 del m22 by del alpha 2 delta beta 2 d alpha 2. Term 3 gives me integral over alpha 2 m12 del alpha 2 delta beta 1 d alpha 2, which is equal to m12 delta beta 1 at the ends of alpha 2 minus an integral alpha 2 del m12 by del alpha 2 delta beta 1 d alpha 2. From 4 we get integral alpha 1 m12 del alpha 1 delta beta 2 d alpha 1 is equal to m12 delta beta 2 alpha 1 minus integral alpha 1 del m12 by del alpha 1 delta beta 2 d alpha 1. Then 5 integral alpha 1 integral alpha 2 q13 delta beta 1 d alpha 1 d alpha 2. This remains as it is, you are not changing it. Okay. Then number 7 is a similar term, alpha 1 integral alpha 2 q to 3 delta beta 2 d alpha 1 d alpha 2. Then number 6, integral over alpha 1 q13 del alpha 1 delta u3 d alpha 1 is equal to q13 delta u3 minus integral alpha 1 del of q13 by del alpha 1 delta u3 d alpha 1. And then the 8th term, integral alpha 2 q23 del alpha 2 delta u3 d alpha 2 is equal to q23 delta u3. Okay, this will be at the ends of alpha 1, this will be at the ends of alpha 2, integral alpha 2 del q23 by del alpha 2 delta u3 d alpha 2. Now if you see, let me change color, this has delta u3 variation, this is delta u3 term, this is a delta beta 1 term, this is a delta beta 2 term, this is a delta beta 2 term, this is a delta beta 1 term, and this is a delta beta 2 term, and this is a delta beta 1 term. Okay, so now on the terms here with integrals, additional integrals, time and the other coordinate will come. So if we put this together in the Hamilton's law, because now all the terms are ready, okay, and remember that there is a negative on the strain energy. Okay, we remember that. What we now get is integral T1 to T2 integral alpha 1 integral alpha 2 del m11 by del alpha 1 plus del m12 by del alpha 2 minus q13 delta beta 1 d alpha 1 d alpha 2 dt. Okay, so I am collecting terms now, T1 to T2 delta of k minus u plus eb plus el dt. We are collecting terms. Okay, so the next term is T1 to T2 integral alpha 1 integral alpha 2 delta beta 2 d alpha 1 d alpha 2 dt. Then we get coefficients of delta beta 2 del m22 del alpha 2 plus del m12 by del alpha 1 minus q23. And lastly, what do we get? Plus integral T1 to T2 alpha 1 alpha 2 del q13 by del alpha 1 plus del q23 by del alpha 2. The kinetic energy term came with a negative rho h u3 double dot plus a q3 delta u3 d alpha 1 d alpha 2 dt. Okay. So plus boundary terms. Boundary forcings, okay, boundary forcing terms and boundary conditions. I am keeping them out for the moment. So that gives us what from here, okay, as these variations can take any form. So each of these terms has to be 0. So from here we get del q13 by del alpha 1 plus del q23 by del alpha 2 plus a q3 is equal to rho h u3 double dot. This is the transverse plate equation. Additionally, we get equilibrium conditions because we ignored rotational inertia. So you get q13 is equal to del m11 by del alpha 1 del alpha 2, okay, and q23 is equal to del m22 del alpha 2 plus del m12 del alpha 1. Okay. Now let us look at m11. M11, as our definition says, is alpha 3 sigma 11 into alpha 3 into d alpha 3. Okay. So that gives me integral alpha 3 e over 1 minus mu squared epsilon 1 plus mu epsilon 2 into alpha 3 d alpha 3. That is equal to integral minus h by 2 to h by 2 e by 1 minus mu squared, okay, alpha 3 del beta 1 by del alpha 1 plus mu alpha 3 del beta 2 by del alpha 2 alpha 3 d alpha 3. Okay. So this results in E h cube by 12 1 minus mu squared into del beta 1 by del alpha 1 plus mu del beta 2 by del alpha 2. We have still not defined beta 1 and beta 2 as the derivation in the textbook goes. Similarly, M22 is equal to E h cube by 12 into 1 minus mu squared into del beta 2 by del alpha 2 plus mu del beta 1 by del alpha 1. and for this plate m12 which is mxy is equal to m21 which is myx, and it is eh cube by 12 into 1 minus mu square into 1 minus mu by 2 del beta 2 by del alpha 1 plus del beta 1 by del alpha 2. Okay. Then Q13 is del m11 by del alpha 1 plus del m12 by del alpha 2, which is equal to del alpha 1 into, I am going to use a substitution, I will call this as D. Okay. So D into del beta 1 by del alpha 1 plus mu del beta 2 by del alpha 2 plus del, this closes here, del alpha 2 into D 1 minus mu by 2 del beta 2 by del alpha 1 plus del beta 1 by del alpha 2. Okay. So that gives me D times del 2 beta 1 by del alpha 1 squared plus mu del 2 beta 2 by del alpha 1 del alpha 2 plus D 1 minus mu by 2 del 2 beta 2 by del alpha 1 del alpha 2 plus del 2 beta 1 by del alpha 2 squared. Similarly, Q23 becomes D del 2 beta 1 by del alpha 2 by del alpha 2 squared plus mu del 2 beta 1 by del alpha 1 del alpha 2 plus D 1 minus mu over 2 del 2 beta 2 by del alpha 1 squared plus del 2 beta 1 del alpha 1 del alpha 2. Okay. So now del Q13 by del alpha 1 plus del Q23 by del alpha 2, that becomes equal to D times del 3 beta 1 by del alpha 1 cube plus D mu del 3 beta 2 by del alpha 1 square del alpha 2 plus D into 1 minus mu by 2 into del 3 beta 2 by del alpha 1 square del alpha 2 plus del 3 beta 1 by del alpha 1 del alpha 2 squared plus d del 3 beta 2 by del alpha 2 cube plus d mu del 3 beta 1 by del alpha 1 del alpha 2 plus d into 1 minus mu by 2 into del 3 beta 2 by del alpha 1 squared del alpha 2 plus del 3 beta 1 by del alpha 1 del alpha 2 squared. Okay. So there are several repetitions. Okay. So we have this term repeats with that term, okay, and repeats with that term, whereas this term repeats with that term. This should be a square here, repeats with that term. Okay. So if you now add all these terms up, what you will get is equal to d is equal to d del 3 beta 1 by del alpha 1 cube plus d del 3 beta 2 by del alpha 2 cube, okay, plus d del 3 beta 2 by del alpha 1 square del alpha 2 plus d del 3 beta 1 del alpha 1 del alpha 2 squared. So mu disappears, and let me remind you that so far beta 1 and beta 2 definitions were not brought in. Okay. So now we bring in the beta 1 definition. So we use epsilon 1 3 is 0, epsilon 2 3 is 0, okay, which results in beta 1 is equal to minus del u3 by del alpha 1, beta 2 is equal to minus del u3 by del alpha 2. So if we now substitute it back, what do we get? We get minus a d del 4 u3 by del alpha 1 to the power 4th minus a d del 4 u3 by del alpha 2 to the power 4th minus twice d del 4 u3 by del alpha 1 square del alpha 2 squared plus a q3 is equal to rho h u3 double dot. Okay, we didn't put that earlier. Okay, plus a q3 is equal to rho h u3 double dot. Okay, so this then ends up as our famous plate equation d del 4 u3 del alpha 1 4 plus twice del 4 u3 by del alpha 1 square del alpha 2 squared plus del 4 u3 by del alpha 2 to the power 4th plus rho h u3 double dot is the forcing. Okay. And so in our familiar form, let me once write it, del 4 w by del x4 plus twice del 4 w by del x square del y square plus del 4 w by del y4 plus rho h del 2w del t square is equal to either 0 or q3, whichever. So that's the differential equation, or that's the partial differential equation. Now the boundary conditions which we left off. Okay. Now remember that the strain energy term comes with a negative, okay, and all the boundary terms will become negative. Okay. So the forcing terms, boundary forcing terms will come with a positive. Boundary forcing terms are positive. So we get integral T1 to T2. Okay, let me do one thing. Time is run out. I'll close this lecture here and continue from here. Thank you.